All right, welcome back, warriors. Let's go ahead and start with what we're doing today. Move my screen over to the lesson. So today we're going to be solving radical equations with extraneous solutions. So we kind of mentioned this a little bit earlier in one of the other lessons, but we're coming back to this. So what we're going to do by the end of this lesson, you should be able to solve root equations and look for extraneous solutions. So before this, there were no extraneous solutions in much of the work. I think there was like one in the one of the other slides, one of the other lessons. And I told you that you should get a really good habit of checking your work before you move on. So let's go ahead and talk about what that means. What exactly is an extraneous solution? So if I asked a student to put something in here, so take the root of this number and you get -2, well, the first thing I'm usually going to get is -4. Well, can I put -4 in there? Well, there's a bit of a problem, and that is you cannot put a negative number into a radical. So I think I mentioned this one last week, but this also doesn't work on another level. If I were to have two numbers multiply to become -4 or become -2, so I'm trying to make -2, I need two numbers that would multiply to 4 or something like that. And usually the answer I'll get is, well, again, -4, but -4 would be this square root of -2 times -2. And that's usually what I'm going to get, which, yes, in idea, in the theory is that it works out. -2 times -2 doesn't, well, actually, it doesn't quite work out because it makes -4, but we still can't take the root of that. And negative times negative will also be positive. So if I were to have -2 times -2, it would be +4, not -4. All right, well, let's just try something else. What if I were to have +2 times +2? I would still get +4. And usually about here, I'll get somebody who says, well, can't you use -2 and +2? Which, yes, that does make -4. But here's the thing. Remember that a square root is the opposite of a square. So I can square -2 and I can square +2, and they would both give me 4. But if I square something like this, they have to be the same number. So they both have to be -2 or they both have to be +2. When you square something, you cannot have one be something and the other be something else. So we tried everything we could think of, and this doesn't work out. We just cannot figure out what we need to put in here to make it work. So again, that's what we call an extraneous solution. So sometimes when you're working on a problem, you might still get the same answer, or you'll get an answer that just doesn't work, even though you did everything the correct way. So in our case, we didn't do anything wrong, but sometimes it just works out like that. Sometimes you just get the wrong solution and it doesn't work out. All right. Sometimes there's just no solution. Kind of like your grandpa fixing that same car for the past 10 years. All right. Sometimes there's just no solution. You just can't get it to work. So let's go ahead and work on an equation here. So I have something going on both sides. So the first thing I'm going to do is -4, because we want to isolate our radicals. We want to get this radical by itself so that when we square it, we only have one item to square. All right, so let's get rid of this 4. So I'm going to -4 on both sides. Now our radical is isolated. So since the radical is isolated, I can go ahead and square both sides and keep things fairly simple. So if I square the square root, that causes the root and the square to cancel each other out. They vanish. So now I have to square 3, which is the only item on this side. And Now, to get x entirely by itself, I just need to move x out of the way. So x equals 7. And if I check it, so I'm going to go ahead and check my work. Now, before I used to tell, I used to just work them out in our, just sort of talk about it, and hopefully you'll follow along in your imagination. And when we do it that way, it doesn't take that long. Usually checking can only, if you're pretty good at it, you can do it in like 3 seconds. But in this case, I'm going to write everything out. So 7 plus 2 is root 9, plus 4 equals 7. And now I take the square root of 9. So square root of 9 is 3. And 3 plus 4 is 7, so it works out. So that means that this is a viable solution. This is a working solution. All right, nothing tricky with this one. This one seems very, very similar to a lot of the other ones we've worked with already. So let's go ahead and move on and try some other ones. So here I have a very tricky one. This one I think is a lot different than some of the other ones we've seen in the past for now. So let's go ahead and in this case here, I am going to have to square both sides because, well, I can't really isolate the radical in this case here. So let's go ahead and just square both sides, and we are going to have to use FOIL multiplication. Not on this side here, because everything here is grouped. So since everything is grouped, I can just undo that group, right? Everything under the radical is now out of the radical. But here I have 2 separate binomials. And when you see that root, when you see that square like this, that means you have 2 of those groups. So I'm going to have to use my FOIL, which is first numbers. So I'm going to move this down. So first numbers is 4. And then outside numbers are -2 root x. So that's these 2 numbers here. Inside numbers, go ahead and put those together. So negative, it's going to be a negative because this sign is telling me that it's going to be negative, right? Because I'm using the inside number, so this is going to be negative. And then times 2 and times root x. So we end up with a second set of the -2 root x. Now here I'm going to kind of skip a step because we know that if you multiply something by itself, that's the same as squaring it. And if you square a square root, they disappear. So there's not going to be any square root on this here because it would be it would be the square root of x squared, right? And the first week and second week, that's what we talked about. Pretty much almost every lesson, that's what we mentioned. Now we have to move some of these terms around because it looks like we're going to have to evaluate this part here. So I'm going to move -x and 12 over here. So -x plus 12. I'm going to have 0 on this side because we don't know. We might end up with something that we do need to square in using quadratic factoring. All right, so now I have -2 root x, -2 root x. I'm going to put those together for -4 root x. And here I have x minus x. So that's going to cancel that out. Oh, I also have plus 12. So that's going to cause 12 plus 4. I really should have put the 12 under here. But anyway, it would still be the same as 4 plus 12 is 16. Okay, now I am going to move this side. So I want to move my x on over to the other side. That way I can make it positive. So we always want to keep our variables positive. So I'm going to add 4 root x to both sides. And I get 4 root x equals 16. I'm a little bit out of space. Let's see if I can move this a little bit. Oh, well, I can do one more step in this case, and that would be to divide both sides by 4. So divide both sides by 4, so I get, I'm going to move my workspace over here, root x equals, and then 16 divided by 4 is, well, 4. Now I have a solution almost. So if I were to square both sides, and that's exactly what I'll do, square both sides. So if I square the root, that goes away. And I have 4 squared, which is 16. And if we weren't checking the work, we might accidentally put this as our answer. But again, this is the whole point on why you check your work. So I'm going to go back to the original equation and let's try this out. I'm going to plug in 16 for x. So this x is now 16 minus 12 and take the square root of all that equals 2 minus square root. And again, we put x, replace it with 16. And there we go. So sometimes I erase a little bit of this stuff here just to make sure that we don't have anything that we don't need and make sure we have everything that we need. So 16 minus 12 is root 4. And here I have 2 minus, and then again, I also have 4 here. So let's go ahead and take the square root of 4. So square root of 4 is 2 right here. 2 minus 4 is negative 2. So in this case, it's not a solution. We only had one solution and it didn't work out. So we're going to go ahead and put no solution. There's nothing we can do for this one. You know, we could try different numbers. We could try negative numbers. We could try fractions. We could try all sorts of numbers. But in this case, it just wouldn't work. And it's not your fault. Let's try an easy one. Try an easier one. So here I have root 5v equals v. Okay, so not a particularly tough one. So I'm going to go ahead and square both sides. So by squaring both sides, the radical will disappear. And here I have v squared. All right, now I end up with, well, I end up with a v on both sides. So I also have a square, and if you remember last week when I was talking about some of these, I said that if you have a square or a 2 power, that means there might be 2 solutions. So let's try that out. In this case, I cannot get one v, so I am going to have to move them both over to the same side. They're not like terms. Even though they both have a v, I cannot add or subtract them. So I'm going to have to leave them separate. V squared minus 5v. Now they both have a v. And I'm going to factor them out using reverse distributive. So in distributive property, you give numbers. Here, I'm going to take numbers. So in this case here, if I were to multiply it back out, v times v is v squared. v minus 5 is negative 5v. And I break it down into two separate equations using the zero product property. So the first one here, my first factor is 0 equals v, and 0 equals v minus 5. Add 5 to both sides. And v equals 5. And v also equals 0. Now in this case, I boxed them even though I haven't checked them yet. So that way we know that there are two possible solutions. Now in this case here, with two solutions, we might have a couple of different outcomes. Let's see what happens. So 0, I'm going to plug in 0 first. And I have 5 times 0, take the square root of that, equals 0. So again, both v's are 0 now. 5 times 0, well, 5 times 0 is 0, and square root of 0. Well, if we take the square root of 0, that would still be 0. So in this case, this is a solution. That one does work out for us. And let's try v now. So 5 is v now. So v is 5 times 5, and this v is also 5. So now I end up with something that looks like this. 5 times 5 is 25. So square root of 25 equals 5. And we are going to take the square root of 5. I'm sorry, 5 is the square root of 5. So 5 equals 5. And this one works out. So in this case, they both work out. Now be careful, just because a lesson introduces something new doesn't mean everything's going to be that new idea, that new process. So in this case here, this one still works pretty well on both of them. Let me just check here. Okay, I got, oh, okay, it's just a little one. All right, we'll see how many we have here. So I've got a new one, just moving right along here. So in this case, it looks like I'm going to have another one where there will be a need to FOIL the number. So square both sides. And let's see, in this case here, this will disappear. Equals, and I'm going to have a FOIL because I'm going to have two sets of these binomials. And I'm going to have to use FOIL property for this. So x times x is x squared. And negative 4x, so outside numbers. Inside numbers, also negative 4x. Negative 4 times negative 4 is positive 16. And I end up with a problem where I am going to have to move everything to one side. So minus x. Now in this case here, I am going to check to see if I can x square, and then I'm going to have to add all these x's up. So negative 4 is negative 8. And I have one more, which would be negative 9. And 18 would be this number here, 16 plus 2. Now I end up with another quadratic. So anytime you have a variable that is squared, you might have to move everything off to one side so that you can get the variable. So you can, in this case, we are going to have to use some factoring. So I'm going to use the factoring of double bubble method. And I usually start with the last number and work my way forward. So I need two numbers that multiply to 18. But if those same numbers are added, they become 9. So let's try that out. 1 times 18. I'm making a list of numbers that I can multiply to get 18, which there aren't that many. I cannot use 4. I cannot use, well, I can use 6 times, not 6 times 9. Well, actually, in this case, it would be, oh, I messed up. That would be 6 here. So excuse me, I have 3 possibilities of numbers that can multiply to 18. So 3 times 6. Now, the reason I start with the last one is because this sign here, in this case it's positive, tells me that these two signs are the same. Because if you remember from, well, actually I have an example in this lesson, and that is if you multiply a negative times a negative, you get a positive, but you can also multiply positive times positive to get a positive. So this means that they are either both positive or they are both negative. And the other clue we have is to look at this middle sign. Since they are negative, that means both of these will be negative. And if we check it really quick, it works out. -3 plus -6 is -9, and -3 times -6 is positive 18. Now, I'm going to kind of I'm going to move a little bit ahead. So if I were to set these both equal to 0, so I get 0, well, let me just do one of them. 0 equals x minus 3, and I add 3 to both sides, plus 3 here, plus 3 there. I end up with 0 plus 3, which is, well, 3, and x equals 3. So again, I have 2 solutions. But I am going to have to check both of these. And again, checking them is important in this case here. So let's go ahead and plug them back in. And I'm going to erase these just so that way I have less stuff to look at. All right, so root, let me make that a little bit better. Root 3 minus 2 equals, and again, we're checking 3, so I'm going to plug in x as 3, so 3 minus 4. So 3 minus 2 is 1, so replace that with 1. 3 minus 4. 3 minus 4 is 1. Square root of 1 is 1. And 1 equals 1, so that is, wait, hold on a minute. 3 minus 4 is -1, which would make this side -1 also, and they don't work out. In this case, this one is not a solution. So even though we followed all the steps, it didn't work out. But we should also check the other one as well. We should check the other option, because this whole problem might have no solution, or it might have one solution. Let me just check something really quick here. Make sure I'm still recording. Don't want to lose this whole video. I just didn't see the little light on. So 6 minus 2 equals, and 4. Oh wait, I need to put x in there, not x. I need to put 6 in there. 6 minus 4. Okay, now let's see if it works out. So 6 minus 2. 6 minus 2 is 4. So root 4 equals 6 minus 4. So 6 minus 4 is 2. And square root of 4 is 2. So 2 equals 2. And I don't think I made any mistakes on this one. So this is a solution here. This is a solution. And that one is not a solution. Okay, so we only have one solution out of this one, even though there were two of them that we could have had. All right, now time to do this one here. So let's go ahead and try this one out. So same thing, I'm gonna have to move this 4 over here. There we go. Now I have to get rid of this radical by squaring both sides. Now there's going to be a lot of these where you will have to square both sides. Negative 3m plus 10 equals, and now I'm going to have a binomial m minus 4 and m minus 4. Multiply that out using FOIL method. Quite a lot of writing in this case here. M squared. So first numbers, outside numbers, negative 4m, negative 4m plus 16. And in this case, it looks like I am going to have to move everything to one side because I need to solve this quadratic. So I'm going to add 3m and minus 10. There you go. I'm going to put them under the other like terms. So m squared. Put all the m's together now. So negative 4 is negative 8. Negative 8 plus 3. Negative 8 plus 3 would be negative 5. And here I have, oh yeah, m. 16 minus 10 is plus 6. Okay, now let's see if we can factor this trinomial using double bubble. So again, start with the last one. So I call it the Loif method, L-O-I-F, because it's just FOIL backwards. So start with the last number. What two numbers can I multiply to get 6? But if I add those same numbers, I get 5, or in this case, negative 5. Well, 2 times 3 gives me 6. But again, be careful with the sign, because this sign, the positive, means that if I multiply it, there are two possibilities. Either they are both positive or they are both negative. In this case, they are both negative because they need to add up to negative 5. So negative 2, negative 3, put them together, you have negative 5. And if you have, for m here, if m is by itself and there's no other variables, then that means that it's just m. So there we go. I have two possible answers, and that is, oh yeah, and don't forget, I need to solve these both for 0. So I guess I could do that over here. Maybe I shouldn't skip any steps on this one, m minus 2. So if I add 2 to both sides, plus 2 here, plus 2 there, m equals 2. And m minus 3 equals 0. So plus 3 here, plus 3 there, m equals 3. So again, there you go. Those are my two possible solutions. M can either be 2 or it can be 3, and I'm going to have to check both of them. So I'm going to go back to the original equation. 4 plus 4 plus the square root of negative 3 times, and again, I'm checking 2 as the solution, so I'm going to plug in 2 plus 10 equals, and again, m is 2, so I'm going to put 2 in there. And let's see what we get. 4 plus, and then multiply these together. Negative 3 times 2 is negative 6 plus 10. And this is basically the same as 10 minus 6. 10 minus 6 is 4. And here I have root 4, which the square root of 4 is 2. So I'm going to go ahead and take that out. So I have, let's see, 4 plus 2 is 2. So this one doesn't work out. So 2 is not a solution. Okay, so this one took a little bit of writing. So I am going to, because if I can't, I don't have enough space to write it again. So in this case here, I'm going to replace it with, I'm going to reuse this part here. So this is all going to be reused. But let's try 3 now. So same thing, I just replaced it with 3. And a lot of this we can still use over again. Here I'm going to put 3. So negative 3 times positive 3 is negative 9. 10 minus 9 is 1. So I have 1 in here. And square root of 1 is 1. 4 plus 1 equals 3. So in this case here, we got neither of them working. And that results in no solution. So in this case, I have neither of them that work out. All right, so I think that's going to be it for today. I do have a couple of other ones, but I'm going to save those for review. But I think we have a little bit of everything. We have some of them that have all solutions. So everything that worked out was a solution. And some where one of them was a solution. And in this case here, we have one that is no solution. So you just do what you've been doing this whole time for the last, since last week on Wednesday and Thursday. You do the same thing, but now we're checking to see if there are any answers that just don't work out. Anyway, so that's going to be it for today. I kind of kept this a little bit shorter also, so it would make a nice video. So if you have any questions, make sure you ask those during the normal class periods. But anyway, that's it for today. If there's no other questions, I will see you later.